This is 4.2 Concepts again, second video talking about the change of base formula. So we talked about the three rules of logs. There's one in blue. There is another one right here in green. Log base b of a over c is log base b of a minus log base b of c in green. The last one is the log of a power. The log of an exponent, log of a number raised to the power is the number, the power, multiplied by the log itself. So right over here is that other rule. So last, another property of logs is the change of base formula. So if we're given something like this, log base 7 of 12, 7 to what power is 12? 7 to the first power is 7, 7 to the second power is 49. Somewhere between 1 and 2, I have no idea though, because we can't figure this out. But we can change the base. So the way that, the reason that we change the base is that most calculators can find logs with base of 10. You can just simply use the button marked log. To find those logs with different bases, we use the change of base formula. Change of base formula. And that change of base formula right here, that's the important thing here. Change of base formula is where we change the base to a log that we can use a calculator for. We write this as log. If we write it as log, we understand that it's a common log. That means our base is 10. But right here, I'll put it down for sure to make sure that we know that it's a log of 10, because then we can use this log key that's in our calculator, because log key uses the base of 10. So we can change this to base log base 10 of 12 divided by log base 10 of 7. And that's where we change our base. We change the base from 7 to 10 because we can't figure this out in the green rectangle. 7 to what power is 12? I have no idea. But we can change it to log base 10 of 12 over log base 10 of 7, and that allows us to use our calculator button. So if we use log base 10 of 12, we can just evaluate log base 10 of 12 as log base 10 of 12 is 1.07918 log base 10 of 7 is 0.84509 and if we evaluate that, equals 1.2769 and that would be our change of base. We're allowed to change the base to something that's a log base 10, and that allows us to use the calculator button that's log base 10. Makes it easier to work with. The last one is talking about graphs. Here's our summary of kind of graphs. Match the log function with its graph. All these are log functions, the red and the blue and the green. And we have to match these with the graph. So remember that if we have, hang on a second, let's see. If we have a log function, x and y, we have to say, well, don't blow it. Log function is always going to go through 1, 0. All these functions go through 1, 0. Sounds good, so they're all okay. It goes, each log function goes through B1. Remember BLLO, the L stands for 1. So BLLO, don't blow it if you're gonna graph it. So we have to find out where the red line goes through at 1, at y equals 1. So at y equals 1, we can kind of draw a line over here. We could say that this one goes through, I'll change that to red, this one goes through 2, 1. So therefore, that's base, 1. That means the base is 2. Base is 2. We've got base of 2, base of 5, base of 10. This one has to be B. Right there, that's B. Graph B is, or I guess B choice is graph 1. All right, so 2, let's go find out what 2 is. Graph 2. Graph 2 goes through, let's see, probably somewhere at 5, I suppose. There's 5, 1, so that point is 5, 1, goes through base, 1, so therefore my base is 5. This one over here must be base of 5, so that one is graph number 2, and graph number 2 is C. Alright, last one, well, by process of elimination, I suppose. I'm on green, so I'm going to change my color to green. This one goes through 1, I suppose right over here about 10. So that one, that point right there is 10 comma 1, and that goes through base comma 1. Therefore my base is 10. Therefore this graph here, graph number 3, is A, and graph number A is 3, or choice number A is 3. And that's how you differentiate between graphs that are going through 1, 0 and going through certain points. It always goes through B1 and 1, 0. All these graphs go through 1, 0, and each one goes through base comma 1, and we have to find out what that base comma 1 is.